Hello, PST class. This is 8.2, and this is just a homework help video, again, to help you get through the homework and get more practice, and to use as a guide to help you through the problems. I know these graphs can get a little confusing, so I'm going to go through 3 examples, and then just so that way you can see all 3 examples that are given in this section. So you should be able to get through each type in your homework that way. So we'll start here. First one is just this most simple case, so it's just going to be working with that a number over x. So we're going to graph it. We're going to state the domain and range. When we graph, we want to use our steps that we have. So first off, let's find the domain and range. I think we can do that here. Let's see. Domain and range. So domain, remember, this is what we can put in. So what can you put into this function? Well, you can put in 1, you can put in 2, you can put in -4, but we cannot put in 0 because we cannot divide by 0. So you can go ahead and do all real numbers, and it's easiest to just do ARN, all real numbers, except 0. Okay? And then what's your range? What are you going to get out? You're going to get out pretty much everything as well, except for 0. Because we have that 4 on the top, so we're never going to divide, we're never going to have 0 divided by something. So you can see that, and this is going to correlate with our asymptotes as well. So we have our domain and we have our range. Next we can move on to graphing. So remember our steps here. We need to find our asymptotes. So we have a vertical asymptote and a horizontal asymptote. So if you remember that the ones that look like this have that vertical asymptote on the y-axis, or at x equals 0. It's the same thing. If you didn't know, it is the same thing. X equals 0 and the y-axis is the same thing. And our horizontal axis will be the x-axis. The horizontal asymptote will be the x-axis, or y equals 0. Those are again the same thing. This is because our vertical asymptote is where the bottom is 0, so we would just have 0 to make the bottom 0. And then our horizontal asymptote is that extra stuff out here, but we don't have anything. We're not subtracting anything off. We're not adding anything, so it's just that. So we can go ahead and draw our asymptotes. Again, these are the dotted lines that we like to use, and I know mine's a little off, but I'm trying to do this with my mouse. Alright, so there's our asymptotes. Now we can go ahead. Next step is to plot points around our vertical asymptote. So we can't use 0 anywhere, so we can go ahead and just go, we'll start with 1. Okay, we can't use 0, but we'll start with 1. So if I plug in 1, I get -4 divided by 1. So I'll get -4. So 1, -4 is my first point. If I plug in 2, I get -2. I'm just plugging in my equation up here. And then I'm going to do 4 because that'll work out nice. -4 divided by 4 is -1. So there's, let's see if I can draw this puppy. There's our first graph. Oh, it's not supposed to touch, but our arrow is kind of touching. That's okay. There's 1. Now let's go the other way. So we're going to do -1. If we plug in -1, we get a +4. If we plug in a -2, we get a +2. And if we plug in a -4, we get +1. So as you can see, it's like the same shape, same type of curve, but on the opposite side here. So there's our graph. That's the first one. You can see our hyperbola. Next up, we get a little bit harder. We add on that extra stuff I was talking about. So we'll start with our domain and range. So again, domain can be anything, I think, here, except for when that bottom is 0. So when is the bottom going to be 0? Well, if we plug in 3, 3 minus 3 is 0, and we cannot divide by 0. So our domain here is going to be all real numbers. Now, instead of 0, except for 0, we're going to do except 3, because when we plug 3 in, we get 0 on the bottom. So for our range, we're going to also get all real numbers. But now, we won't ever get out what we would get if we put 3 in. And that would sort of be like, if we put 3 in, we'd get like undefined, but then we'd add on this 2. So technically it'd be all real numbers except for that 2, extra 2. So again, this corresponds with our, oops, bad handwriting here. This corresponds with our asymptotes as well. So if we move on to the asymptotes, the VA, the vertical asymptote, is again where that bottom is 0. So again, that corresponds with our domain here. So that's going to be when the bottom is 0. If we plug 3 in, 3 minus 3 is 0. So that's going to be at 3. X equals 3, because that will make it vertical. Horizontal is that extra little bit, so that's 2 when y equals 2. So if we want to plot our horizontal and vertical asymptotes, we can go ahead and find vertical asymptote. We said is at x equals 3. So if we go to x equals 3, 1, 2, 3 over, and make that vertical line at x equals 3. And then our horizontal is at y equals 2, so we go up 2, and then we make our horizontal line. So there it is. So now that we have that, we can go ahead and plot points that are around it. So we can't do anything up to, we can't do 3, but we can do everything else. So let's do 4. So if we plug in 4 over here, we get 4 minus 3 is 1. 1 divided by 1 is 1. So 1 plus 2 is 3. So we'll get 4, 3. Alright, I'll try to pick another one here that would work. Yeah, there's not really one that would work too well, but we'll do 5. So 5 minus 3 is a half. So 1/2. 5 minus 3 is 2. So we'd have 1/2 plus 2, which would be 2.5. So we'd have 5 and then up to 2.5. We have 5 and then up to 2.5. Okay, and then we'll do 6. We'd have 6 minus 3 is 3, so 1/3 plus 2, we have 2 and 1/3. So it's gonna get like a little bit smaller here. I'm sorry, my lines are just not. So there it is, kind of not the greatest drawing. Now we'll try the other way. So we can't do 3, so we'll do 2. So 2 minus 3 is a -1. Okay. -1 plus 2 is 1. So we have negative. So we're plugging in. What are we plugging in here again? 2. So 2 minus 3 is -1. 1 divided by -1 is -1. -1 plus 2 is 1. So sorry about that. We'd have 2 and then up 1. Okay. Next one we'd have, let's plug in 1 here. So we have 1 minus 3 is -2. So we'd have a -1/2 plus 2. So that'd be positive 1.5. So we'd have 1 to 1.5, I think, there. And then we have, let's plug in our 0. So we'd have -1/3 plus 2. Okay, so that would give us 1.66. Just trying to make sure my graph is going to turn out. So we want to go to 0 up to close. All right. So again, I'm drawing with my mouse and down. Perfect. There we go. It's not the greatest drawing, but you can get the gist of it. So there is our next example. Sorry about my mess ups. I just want to make sure my graph turns out for you on this as best as I can. I'm just kind of looking at my graph on my calculator, so just making sure it looks great. And it does look pretty good. So the next one, the last one we have is this scenario. So now we have x's on both the top and bottom, and then we also have something added on as well on that top and bottom. So it's a little bit different looking here. So we're going to go ahead and find the domain and range. So again, the domain is everything but where the bottom is 0. So we'll go ahead and do that. Domain. So the bottom would be 0 if we solved here. We'd add 3 and we'd have x equal to 3/4. So our domain corresponds with that, all right? So we'd have all real numbers except for that 3/4 that we just found. Except 3/4, okay? And then that range up next. That range will turn out to be, and you'll see this is where it gets a little iffy. You'll see this when it comes to the horizontal asymptote. It's going to actually be all real numbers except for 2/4, or that would be 1/2. And that has to do with these coefficients out front here. Okay, so that leads us into our asymptotes here, and I'll explain that. We want for our vertical asymptote, again, that's where the bottom is 0. So you can see here that our bottom will be 0, like we found in our domain. Our bottom will be 0 at x equals 3/4. Okay, and then our horizontal asymptote, whoa, my bad, will be at y equals our coefficient. So we can go ahead and take a divided by c, or in this case it's 2 divided by 4. So again, that would be the same as taking our 1/2. So yeah, this one's a little bit different and it's a little bit more confusing, but there's guidelines and you just follow it. So take that bottom, find when it's 0 for the vertical asymptote, and take the coefficients and divide them out for our horizontal asymptote. So we can go ahead and do this. So vertical is going to be at 3/4, and this is going to be as best as I can do it, you guys. I'm not quite at 1 here, but ugh, it's not good. Oop, but you'll get the gist of it. And then we have 1/2 for our horizontal. So again, I'm trying my best. And I'm doing this with a mouse. So that's at 1/2 as best I can do it. And then we go ahead and we do it again. We plot the points. So we can go ahead and we can plug some points in here. And if it's easier to just use a calculator, that's okay. I know these, you just want to make sure you get it right because we got a lot of numbers. So let's go ahead and plug in. We can't plug in 3/4, so we'll plug in 1. Let's do that. So if we plug in 1 on top, we get 3. And then if we plug in 1 on bottom, we get 1. So it's 3/1. So 1 would bring us to 3. So we have 1 and then go up 1, 2, 3, and that's really close. So then we can go ahead and do, let's just do 2. Let's go next, the next one. So if we do 2 on top, we get 5. And if we do 2 on bottom, we get 5 as well. So that worked out nicely. So we do 2 up to 5. So five. Okay. Oh, excuse me, not 5. We have 5 on top and 5 on bottom. That gives us 1. I'm sorry about that. So we have 2 and then 1 there. Sorry about that. There we go. That looks better. And then we can go ahead and plug in 3, see what we get. If we plug in 3 on top, we get 7. If we plug in 3 on bottom, we get 9. So 7/9, which is close to like 0.788. So it's almost to 1. So we go 3 and then like almost to 1. Again, doing the best I can with this. There we go. Let's do the other side. So we can't plug in 3/4. We'll go to 0. That's the next closest. So if we plug in 0 on top, we're going to get 1. If we plug in 0 on bottom, we're going to get -3. So we have 0, -1/3. See if I can do this right now. So there we go. If we plug in a -1 on top, we get -1, because -1 times 2 plus 1 is going to give us that -1. If we do a -1 on bottom, we are going to get a -7. We have let's go back and check this here. So we have 2 times a -1 equals -2 plus 1 is going to give us that -1. We have 4 times a -1 equals -4 minus the 3 is -7. So this is weird. It'll be 1 divided by 7, which is like a 0.1428. So yeah, my asymptote should be at 1/2, but it's kind of saggy, so it's gonna be like really close to it, but it's like really close to 0. We'll do one more point. We have -2 times 2 on top is -4 plus 1 is -3. Bottom plug in -2 times 4 equals -8 minus 3 equals. So we have 3 divided by 11, and that's going to bring us a little closer to that 1/2 as well. Oops, back. 3 is going to be, it's like 3, it's almost 0.3, it's 0.27, it's 0.2727 repeating. So we got -2 up to that 2727. And again, my asymptote is off a lot because I'm using my mouse. So again, yours will look better than mine. And like I said, it's just all about finding that domain and range and your asymptotes and then going from there. And you can see that took me a while just to figure out what was going on and plug it. I would use a calculator on these tough ones because it gets a little confusing with all those numbers. So just taking your time and doing your best. And as you can see, I make mistakes and I get off if I just don't take my time. So just take your time and work it through. If you have any questions, let me know as always.